Good day, everyone. This is another tutorial on Seaborn. Okay, Seaborn is a data visualization library that is based on Matplotlib. It is tightly integrated with Pandas library and provides a high-level interface for making attractive and informative statistical graphics in Python. Okay, so let's import the relevant libraries to help us do this. So we're importing Pandas, Matplotlib, and Seaborn, right? And then we'll set Seaborn. And let's get started. Loading the datasets and inspection, right? So we did this in the Pandas tutorial, so we know how to load the datasets. You know, inspect it. You can inspect using the sample, the info, and let's get right into the Seaborn, right? Scatter plot. We shall plot the age and credit amount columns using the joint plot function. So one of the plotting functions in Seaborn is the joint plot. Okay, so the joint plot is like, you know, scatter plot, right? It's like a combination of scatter plot and sort of a histogram, right? And so when we look at this graph, you can see a scatter plot, and then you can also see a histogram, right, of the age, and you can see a histogram of the credit amounts, which is why they call it joint plot. Okay, and the parameters are the x, which is the variable, the column that you want to, indicate as your x, and then the y, and then the data is your data sets. Okay, um, yeah, and then let's plot the age and credit amount again, but this time let's break that with job. For this, we shall use the rel plot, which is the relationship plot. This function provides access to several access level functions that shows the relationship between two variables, which can also come with semantic mappings. Okay, it also come with a kind parameter which can be used to specify whether you want a line plot or a scatter plot. The default is scatter plot. Okay, the visualization below shows the relation between credit amount given to people and their ages. In addition, I am comparing it over the kind of job. Seaborn uses coloring to show which of the points represent what kind of job. The height and aspect parameter is used to adjust the height and width of the facet grid. The hue parameter helps to group variables that will produce elements with different colors. Data parameter represents the data sets of interest. All right, so with the rel plot function, we have the x, we have the y, which denotes the various columns. We have the height, which is the height of the graph, and then we have the aspects, which also help us with the width as well. And then we have the hue, which is the job, right? And so you're going to plot this, and then each colors will represent each job value, okay, which is skilled, unskilled, high, qualified, or unemployed, and so on and so forth. And our data is our data sets, okay. So when we plot that, this is what we have. This is what we have, okay. And then we can also plot the above visualization where we compare what it looks like over two or more categorical elements. Okay, so for example, in the below visualization, we shall compare the above visualization over class using the call parameter in the rel plot function. Okay, so it is the same as what is above, but what we are doing is that we are using the class column, which has two values, which is good and bad. Okay, and so we are trying to say that for age and credit amounts, right, for the good ones, how does it look like, and for the bad ones, how does it look like, right? It helps to compare across two or more values in a categorical or in a across a categorical variable. Okay, so that is what you have, and you still have dark colors as well, which represent the job. Okay, so we go to the box plot, right? A box plot. A box plot is used to show the distribution of numerical values and facilitate the comparison across multiple categorical values, right? We would like to visualize the distribution of age of the customers with respect to class. Okay, so the age, and then we have class, which is either good or bad, right? And so you're looking at the distribution of age, across good, and a crossbar, right? So you have that. And let's visualize the distribution of credit amount with respect to purpose using class as the hue. Okay, and so we have the box plot, the purpose as the X, the Y as a credit amount, and then the hue as a class. And so we have good, bad, and they all have different colors, right? Blue for the good, and then um, this color, I'm not sure what color it is. It looks like brownish for bad. Okay, and it it helps to do some level of comparison, right? So this line of code you see here is just to help us with the figure size. Okay, and so we have that, and then we have it over here. Ax is equal to ax. Okay, and then we go to histogram. So histogram represents the distribution of data by forming beams along the range of the data and drawing lines to represent the number of observations that fall within each beam. Okay, so in Seaborn we used a dist plot to plot histogram. Okay, so we take the credit amount column and then we plot it, and this is what we have. Okay, and then we can also plot the age as well, and you have that. And you can also plot across multiple values in a categorical column. Okay, so you have your CS over here. So you have your CS, which represents the data set, and you have the height, which is the height of the graph, and then the column, which is class, right? And so what we're saying is that we want a histogram for the good, and we also have a histogram for the bad as well. Okay. And you can also do the two things on the same graph, right? Just to facilitate comparison, right? When it's this way, it's hard to compare it very well, but when it's this way, it's easier to compare. Okay. Then we go to the line plot. Okay, so the line plot, we're not going to use the data set we've been using so far. We're going to use the iris data set, which comes with Seaborn. Okay, so essentially what we're trying to do is that we are trying to create a data frame, right, using a pd.dateRange function in pandas. So where we indicate the start dates and then the period. So trying to say 36 and the frequency is 12 months, right? And so that's going to be 1970 plus 36, right? So that's where it's going to end. And then the duration, the duration, we just want the duration, which is the first 36 rows in the duration column, and then the first 36 rows in the age column as well. And when we do that, we see the head. This is what we have. Okay, so next we're going to move the duration and the age column to rows so that we can plot both on the graph. We are going to do that using the pandas melt method, right? So the melt method allows us to unpivot a data frame from a wide to a long format, optionally leaving the identifiers set. It takes in the data frame you want on pivots. The ID vars, which is the identifier variable, could be a single column or a list of columns. And then the var name, which is a variable name for the variable that are going to be unpivoted, and the value name, which is the name of the value column. And so when you look at this data set, okay, what we're trying to do is we're trying to use time as the identifier variable, right? And we want to unpivot the duration and the age. And so when we do that, this is what becomes. Right? So we have the time just as we have over here, and then we have the duration and the age unpivoted, right? And so it all comes into one column with the name variables, and then its values are over here. And so the new series represent the data sets that the new data sets we've created, and then the ID vars represent the time which we are using as identifier variable, and then the var name, which is the name we want to give to the unpivoted duration and age, is variables, and then the value name, what the name we want to give to the values of the unpivoted variables, right, is values, right? So now we can do our line plot, right? So we use the line plot method or function, which has the x, the y, the hue, which is the variables, duration and age, and then the data, which is the series, right? And this is also very similar to a time series plot. This is also very helpful when you're plotting a time series, where you're trying to compare values over a period of time. How values go up or decline over a period of time. Okay, and so that is what you have. And the good thing is you can compare multiple variables, right? So we have the age, and then we have the duration as well, right? And see, you can also, it helps you also compare how one variable is compares to the other one. And then we move on to regression plot. Okay, and so with the regression plot we're going to use, okay, sorry, so for this one we just created a new data frame. We created a new data frame using the columns in the old data set. Okay, but this is where we use the iris data set from the Seaborn module. Okay, and so we say iris is equal to sns.load dataset iris. Okay, and then we use a sample method in pandas to check, to randomly see 8 rows. Okay, and then we want to plot the regression using the LM plot, which is sort of like a linear model plot, right? It takes in the x value, the y value, the order. So the order, if the order is 1, it means you want a linear. If it's 2, it means that you want a quadratic. If it's more, then the degree goes on like that. Okay, so right now it's 1, which is a linear. Let's try 2. Let's look at how 2 looks like. Okay, this is 2. It's mostly straight, so you wouldn't see much difference. Let's try 3. Right, so this is what you have for 3, and so on and so forth. Let's try 5. Right, so this is what you can also have for 5, and so on and so forth. Right, so that is that. And then the data, which is iris, right, and then we label it. Right, and using the species, let's break the regression line with respect to the species and fit the first order regression to each species respective data point. And so essentially what you're trying to do is that there are a number of species, which are setosa, versicolor, and then virginica. Okay, and so um, we want to analyze the petal length. That we want to analyze what do you call it? The relationship between the petal length and the petal width across the species. Okay, and so this is the setosa, this is the versicolor, and this is the virginica. Okay, and this is how you do. So it takes in the LM plot, takes in the x, the y, the hue, which is the species, and then the height to represent the height of the graph, the order, means a straight line, and then the data. Okay, and then we have the axis labels. Okay, and instead of putting everything on one graph, you can also separate them, right? And this one, instead of using the hue, you use the call, right, to get it, to separate them into 3. Okay, so yes, so the aim of this tutorial was to introduce you to some of the common plotting functions in Seaborn, and then how they are used, right, on a data set. You can definitely go to the seaborn.pydata.org to learn about more functions, and then more importantly to learn about the various parameters that those functions also have. You need to research more in order to make your visualizations more powerful and more informative. All right, this is my great. So we've made it to the end of the Seaborn tutorial. There's going to be some task or assignment for you to do, for you to help you practice your Seaborn and put it into action. Okay, so here's a reference to so the future ranking reference shows, is a website where I modeled my tutorial after, and then the seaborn.pydata.org is the Seaborn documentation. So you can go there. So these plotting functions and methods are not the only ones in Seaborn, and so you want to go to these websites and even more, right, and learn more about Seaborn and put your Seaborn into action. Okay, so we're going to share the assignment with you, and do well to do it, and do it very well. Okay, so thank you so much, and catch you in the next tutorial.